So good evening, everyone. Welcome to this lecture, and we are dealing with Gauss law in electrostatics. Your favorite topic since quite long. We have been waiting for this topic, and finally, we are now on to it. In the last section, in the last class, we had dealt with, I think, some very typical, some great questions where we had found out the flux due to point charge, flux due to different type of charge combination, and we had also seen this particular thing where we had found out the solid angle. And I told you, remember this concept, because if you ever get a question on circular thing, on circular finding the flux through the circular part, this is what you might need to solve it. Everyone remembers this? Yes or no? Now you are only expected to find this question in a JEE Advanced, not in JEE Mains, because this is probably beyond the domain of JEE Mains. Then we had started with our favorite Gauss law, number of electric field lines passing through a surface, and we had seen that if it is a closed surface kept anywhere in space, anywhere in the universe, to find out the flux through this closed surface, just find out how many charges are inside and divide it by epsilon naught, and you are done. And this is a universal law, and we had given some very interesting facts about this one. We had also seen that you can call it as a surface integral of electric field over a closed surface. That closed surface is known as your Gaussian surface. And I also told you in that flux, we have this electric field, which is now I'm going to highlight in yellow. This electric field is the net electric field reduced by all the charges everywhere in the universe. So remember that. That's why this Gauss law becomes a very, very potential, very, very big concept. And I had given you some points onto that. Flux through the Gaussian surface is independent of the surface. It only depends on the total charge. It is independent of the position of charge. It is independent of the type of electric field it is put in. Incoming flux is taken as negative. Outgoing flux is taken as positive, and all those points. Do we remember this? Yes or no?
Yes, sir. Yes, sir.
Now, sometimes what will happen is you will have, and I'll give you a question, don't worry, and I'm looking if I can get a question which is already there, so I can just use it, and so that I don't have to draw it. This one is already there, so yes, that will make a point also, and that will help you in understanding what is there. So let us start with a question rather than giving you a theoretical point. Let me start with a question, and with this we can understand this theoretical point about this. Now this is the question. That's a very simple question. Find out the flux through this Gaussian surface. Now remember, Gaussian surface is a closed surface. It might look like a loop here, but this is not a loop. This is a three-dimensional space, and it's a surface. It's a Gaussian surface. It's a closed surface. You have to find the flux through this Gaussian surface. Remember, now what point I want to make? You can see three charges are inside this Gaussian surface, and there are three charges which are outside this Gaussian surface. Now remember, whenever we are doing any question in electrostatics or gravitation, whatever charges are given in the question, those are the only charges present in the entire universe. Do we understand this? So apart from that, there are no other charges or no other masses present. So in whatever universe this Gaussian surface is put, there are only 6 charges in that universe. And out of those 6 charges, 3 charges are inside and 3 are outside. Remember, electric field is produced by all the 6 charges which are in the universe. In this universe, there are only 6 charges. They are creating their own electric field, and you have to find the flux through this Gaussian surface. What is the answer? Flux through this Gaussian surface.
3 microcoulombs by epsilon naught.
3 microcoulombs by epsilon naught. So what do you do here? You find basically the net charge in the system. And what is the net charge in the system? If I make this pink surface as the Gaussian surface, the net charge is 2 plus 4, 6. These are positive charge, minus 3. So the net charge becomes plus 3 microcoulomb. So the Gaussian surface, the flux through the Gaussian surface simply becomes, remember this is the flux of the net electric field produced by all the charges in the universe. So flux through this Gaussian surface is 3 microcoulombs, so 3 into 10 raised to the power minus 6 divided by epsilon naught. That is the flux through this closed Gaussian surface. Do we understand this? Yes or no?
Yes, sir.
Okay. Now, as I told you, I mean, did I tell you this point or not? Yes. Point number 6. If you see that the flux through any Gaussian surface is 0, that does not mean that the electric field is 0. Now, this is a question that may come as an objective question. If the flux through any Gaussian surface is 0, does that mean that electric field is 0? No. The electric field may be still there. The only thing is there is no net charge inside that Gaussian surface. So electric field is 0. The flux is 0. That does not imply that electric field is 0. But if electric field is 0, then the flux has to be 0, because if there is no field, there is no flux. Do we understand this better?
Yes, sir.
I'll give you 1 minute. We remember this? We understand this? Okay. We have found out the flux due to this. Now, in some cases, the flux can be 0. What is the case in which flux is 0? One of the cases is your favorite, which you have already done. And what you have already done is electric dipole. Electric dipole is nothing but a combination of two charges separated by a very small distance. The net charge of an electric dipole is 0, but that is not the charge of a dipole. The charge of a dipole is the charge on the positive charge. Remember, we will come to dipole. Don't worry about that. Here, if there is a dipole inside a closed surface, the net charge of the surface is 0, and therefore you will have the electric flux as 0. But remember, here the flux is 0, but electric field is not 0. Do we understand this? Because these charges are going to create its own electric field, their own electric field. The electric field is not 0, but the flux is 0. So flux 0 only implies that the net charge is 0. If the net charge is 0, as in the case of a dipole, it may not be a dipole, but you can have a combination where the net charge is coming to be 0, then the flux is going to be 0. And in that case, if the net charge is 0, the flux enclosed will be also 0. Do we understand this?
Yes, sir.
So basically, flux through any closed surface, if it is coming as 0, that means there is no net charge involved inside. Do we understand this? Yes or no?
Yes,
Yes
sir.
or no? Now, if you have a closed surface placed inside a electric field, it may be a uniform electric field, it may be a non-uniform electric field.
Sir,
If
once
there is,
previous slide.
yes, beta.
Once show previous page.
Okay, this is the previous one.
Yes, sir.
Can I move on to the next one? In the previous one, there are two pictures. One only has a dipole, the other one has the net charge as 0. Okay. Do you understand this? Shall we move ahead?
Yes, sir.
Okay. In the next diagram,
No,
what?
sir.
Okay. Chill. Let me know once you are done.
Done, sir.
Boys done? Gentle boys.
No, sir.
Arey? Boys are always behind.
Done, sir. Done, sir.
Now remember, if you have a closed surface, it may be placed in a uniform field. If it is a uniform field, the always charge enclosed will be 0. If it is a uniform, non-uniform field, when the charge inside is 0, that closed surface, the flux is going to be 0. So even if you have a closed surface which is placed in a non-uniform field, if there is no net charge in that field, sorry, the no net charge in that surface, the flux is going to be 0. In some cases, you will find that the flux is not coming as 0. The flux is not coming as 0. That means that there is a charge inside that surface. I'll just take you to the question that we had done. See, bacha. This is the question that we had done, one of the questions. Should remember this question. There was a point charge and I asked you to find out the flux to the curved part. And how did I do it? I closed that I closed that hemispherical part with a cup, and then I told you that there is no charge inside this sphere, inside this hemisphere, so the total flux will be 0. So whatever flux is incoming, the same flux is outgoing. Do you remember this? Remember this? This surface was placed in a non-uniform field. There was no net charge inside it. That therefore the flux was 0. Do we understand this? Are you getting my point, bacha?
Sir.
If I come to this question where I had this different types of fields, when it was in uniform field, the flux was always coming as 0. In this particular field, the flux was not coming as 0. That means this type of field can only be created when there is a charge inside that Gaussian surface that we had created. Do we understand this?
Yes, sir.
But the last field, which was again non-uniform field, the flux was coming as 0. That means this field can be created by a charge which is outside the Gaussian surface. Do we understand this? In general, if there is no charge inside the closed surface, the flux is going to be 0, whether it is uniform field or whether it is non-uniform field. This is what it is illustrated in this diagram. I'll give you 2 minutes to note it down.
Done, sir.
No, sir.
I will wait, sir.
Done, sir.
No, sir.
Shall we move ahead?
Yes, sir.
Okay.
Sir.
Now remember, one of the important points that you must remember whenever you are applying Gauss law or doing any question using Gauss law is the symmetry. You can write it as an important point. Symmetry plays a very important role in Gauss law. Symmetry plays a very important role in Gauss law. 99.9% of the questions are done with the concept of symmetry. How? And this is one of the very peculiar question that has come many times in different ways. This is a charge placed at the center of the cube. Now, this is known as a face center cube. Face center cube. You must have heard this term in chemistry. Have you heard it? FCC, face center cube. Yes or no? Physical chemistry. That is the only chemistry that I understand. Have you seen physical chemistry? FCC, BCC. This is not FCC, this is BCC. Body center cube. FCC.
No, sir.
Eh? That is not there in the course anymore. Body center cube and face center cube. Anyway, at some point in time, it was, while I was of your age, that was a part of the course. Forget about it. Now, if you place a charge q at the center of a cube, the flux through the entire cube, because it is a closed surface, it is going to be q by epsilon naught. We understand this? Yes or no?
Yes, sir.
Now, since the cube is at the center, I don't have a cube, but I have this box, and this box has helped me a lot. This is a cube, and if I place, this is the charge at the exact center of this, all the 6 faces, face number 1, face number 2, face number 3, face number 4, face number 5, and face number 6, they are equidistant from the center of the cube. Yes or no? So flux through all of these 6 faces would be same. Therefore, flux through any face will be q by 6 epsilon naught. Do we understand this? Huh?
Yes, sir.
But if the charge is not placed at the center, if I offset it from the center and let me place the charge somewhere here, not at the center, then remember the flux through the entire cube is still q by epsilon naught, but the flux through the different faces will not be all same. They will be different. Do we understand this?
Sir.
How do you find out which phase they are going to be same, which phase they are going to be different? I will try to make you understand that. So this question of this type has come in previous year JEE, but do you understand that symmetry plays a very important role here? If it is exactly at the center of the cube, flux through all the 6 faces will be same, and that will be equal to q by 6 epsilon naught. This is what you need to understand. We understand this, yes or no?
Sir.
Now, this was a BCC. When I say BCC, that means body center cube. Now we have a brother of this body center cube, and that brother is known as the face center cube. Have you noted this body center cube first?
No,
Huh?
sir.
Shall I move on to the next one?
No, sir.
Okay, then I shall give you time. 2 minutes.
Done, sir.
Now boys are doing faster than girls. Good. I like this competition. Competition in the right spirits is always good. It helps us in improving. Any competition which is done in the right
Completed,
spirit
sir.
is always good.
Done, sir.
Done, sir? Everyone, sir?
Yes, sir.
Yes, sir.
Okay. Then I think I should move on. Just give me a minute. I was looking at a question and I just missed it. Okay. So this was a body center cube. Now I come to the next one, which is the FCC, face center cube. Now you can see, bacha, there is a charge placed at the center of the cube, and just pay attention because this is symmetry, and symmetry from this chapter, symmetry is going to play a very large load coming forward. This is placed at the center of this face. Do we understand this? Now, if someone asks you what is the flux through the entire cube, how are you going to get the flux through the entire cube? Remember, when it is at the face center, the entire charge is not enclosed. It's only half of the charge that is enclosed. But Gaussian law is not valid for half of a charge. So what do? You take an identical cube and you enclose it. Do we understand? This is an identical cube, face flush with that face. Now this entire bigger box, the total charge enclosed is Q. Do we understand this? Huh?
Yes, sir.
That means the total flux through this entire structure is Q by epsilon naught. Do we understand this? That means the flux through this green structure would be Q by 2 epsilon naught. This is what we understand by symmetry. Do we get this? Yes or no? Yes or no?
Yes.
Yes, sir.
That is the flux through the entire cube. Now remember, there are 6 faces of this cube. There are 6 faces of this cube. On one of these faces, where my cube went? On the center of one of these faces, this one precisely as a diagram, the charge is placed. So remember, the flux through this face is going to be how much? What is the flux through this face? Huh?
Q by 2 epsilon naught.
Q by 2 epsilon naught. Through one face, Q by 2 epsilon naught. What are the other face doing? Chilling out. Face, this face.
Q by 6 epsilon.
Problem with us is that we forget. Gajani only looks good in a cinema hall. It is not favorable for students, especially who are preparing for JEE. Definitely, becoming Gajani is not one of the strong points that you can have. This was a square. Charge was placed at the edge of the square. What was the flux through this square?
0.
0. Sometimes 0 is the hero. If I place this charge at the center of this square, what is the flux through this square? Huh?
0.
0. Sometimes 0 is the hero. In fact, 0 is always the hero. You put 5 zeros with your salary, and if you get the 6th one and the 7th one, you become a Sundar Pichai, right? And if you take out 4 zeros from your salary, from the salary of Sundar Pichai, you become Aste Gudenia. So zeros are heroes here. Zeros are heroes here. 4 zeros, Sundar Pichai. 4 zeros come, me. What is the flux through that square? This side, this face.
0.
0. 0 is the hero here. So flux through that phase is 0. But now you look at the symmetry of the diagram. The charge is placed exactly at the center. Do not look at this diagram. There's nothing in the diagram to look at. The charge is placed at the center of this. Now, what is going to be the flux? From which phases is the flux going to be same? Do not write everything that is given there. It may not be correct. Someone may have given the wrong Yes. At the center of this sphere, at the center of this phase, I have my point charge. Now there are 5 more phases here. Number 1, number 2, number 3, number 4, and number 5. What you have to look is the symmetry. Through which phases is the flux going to be same? And through which phase is the flux going to be different? Let me name it for you. Let me call this lower phase as phase number 1. Lower phase. So let me not write it here, otherwise it will create a confusion. The lower phase is phase number 1, the niche wala phase. The upper phase is phase number 2, upar wala phase. The front phase is phase number 3, front. The back phase is phase number 4, and this side wala phase is phase number 5. Through which phases is the flux going to be same, and through which phase the flux is going to be different? And there was a question from your JEE. Imagination, and someone had a Rubik cube, so that Rubik cube can help now. Symmetry plays a very important role in Gauss law. Symmetry plays a very important role in Gauss law. Yes, bacha. Anyone with an answer?
Sir,
Yes.
1 and 2 is same and 3 and 4 is same. By 5, it's different.
1 and 2, it's going to be same. 3 and 4, it is going to be same. 5, it is going to be different. Is there any relation between that 1, 2 wala flux and 3, 4 wala flux? Or 1, 2 wala flux will be same, but it will be different from 3 and 4. I hope you understand my question.
Yes,
Let us say that the flux through 1 and 2 is x. And let us say the flux through 3 and 4 is y. And let us say that the flux through 5 is z. Is there any relation between x and y? 1 and 2 is correct. 1 and 2 would be having the same flux. But 3 and 4, which has the flux y, does this x and y have any relation? You have to understand the symmetry, my dear friend. Symmetry. Symmetry. And the answer for the symmetry is actually 1, 2, 3, and 4 all will have the same flux. Do we understand this?
Yes, sir.
Because all are symmetrical with respect to each other, with respect to the center of the face. All are symmetrical. Let me bring out my cube. The charge is placed here. You look at this surface and you look at this surface. It is symmetrical with respect to this. But look at this and this. It is also in the same orientation, in a different plane. You look at from this to this, the distance is a by 2. You look at from this to this, the distance is a by 2. It is placed symmetrically with respect to this face as well as this face. Do we understand this? We understand this?
Yes, sir.
So the flux through all the 4 faces would be same, but the flux through the 5th one, which is right in front, would be different. Do we understand this?
Yes, sir.
Flux through 1, 2, 3, and 4 would be same. Flux through the 5th one would be different. Do we understand this?
Yes, sir.
And flux through the entire cube will be q by 2 epsilon naught. Flux through the phase on which that charge is kept is going to be 0. Yes or no?
Yes, sir.
Everyone got this? Huh?
Yes, sir.
Okay. Remember, symmetry plays a very important role in what? In Gauss law. And I've seen questions on this. That's why I'm spending so much of time on this, for you to understand symmetry. Have you noted it down?
Yes, sir.
Everyone? Oops.
Yes, sir.
Now, I get one more cube for you to play around. This is my cube. AB, CD, E, F, GH. We have seen what happens when, remember all these are questions, they are not theory, they are questions. Remember, we have seen what happens when you place the charge exactly at the center, which all the 6 faces it is same. We've also seen when you place the charge at one of the faces. Now I've placed the charge as one of the edge centers, edge center cube. So I place the charge here. I place the charge between midpoint of C and B. Now again, you have 6 faces. Through which phase is the flux same? Through which phase is the flux different? Is there any phase through which the flux is 0? You have to understand the symmetry, my dear friends. Symmetry is what you have to understand. Symmetry. Symmetry. And you have 2 minutes to answer this. Now you can name the faces. So in my diagram, you can name it. Take your time. Understand the symmetry, because I will be needing it. I would be needing this symmetry, not only in this question, but in things that are coming up. We will be needing this symmetry. You have to understand this symmetry. Through which phases do you think are symmetrical and the flux is going to be same? Through which phase do you think not symmetrical and the flux is going to be different? And I wait patiently for your answers, my dear friend. I'm so patient. Yes, bacha. Anyone with an answer? Huh? Or shall I do the needful? We understand the question, yes? Or no?
Yes, sir.
Yes, beta? Everyone understands the question, yes or no?
Yes, sir.
Sir, A, B, C, D and C, G, F, B, 0, sir.
A, B, C, D and B, C, F, G. The flux is how much?
0.
Well done. Through A, B, C, D. Flux through A, B, C, D will be same as flux through B, C, G, F. And the answer is 0. Well done. Next. Which is same, which is different? And I'm looking for that question. If I can get it, I will be able to show it to you. Yes.
ABF and DHCG is same, sir.
Where is that?
Bottom.
Yes, which one? The bottom and the top. The flux is same. The bottom and the top, the flux is same. Correct? The bottom
Yes,
one
sir.
and the top one, the flux is same. But there are two more remaining. What are the two more that are remaining? Bottom and the top, the flux is same. The bottom one is, let me name it so that everyone understands it. The bottom one is ABFE will be equal to the flux through DCHG. Flux is same. Two more are remaining. Will I get an answer? Yes, sir, or no, sir? No, sir.
DHC and HCFG is same, sir. 0.
Yes, so 0. No. How it is 0? No. It's not 0. It's same, but it's not 0.
0, sir. Same, sir.
Not 0. The remaining two phases. So the phase which is EFGH, flux through EFGH, the front and this front, AEHD, this would be same, but these two would be different from each other. Do we understand this?
Yes, sir.
This is what we say symmetry. Have you understood the symmetry, or it has gone above our head saying bye bye? Bye bye, sir, the symmetry is gone.
Understood, sir.
Where is that? Everyone understands this? Hey, everyone got
Yes,
this?
sir. Yes, sir.
Just wait. I'm looking for something. Okay, it is here. After this, let me see if I can get that question. I remember the question, so there must be there somewhere. Where is that somewhere? I can't remember a question which is not there. It must be somewhere. Where is that? Where is that? Where is that? Have I missed it? I can't miss it. Somewhere it must be there. Where? I can't find that question. Strange. I see. It's not possible that I remember a question and it's not there. This is a question probably I was talking to you about, and this is from JEE Advanced of 2014, 2012. So the question is here, and I think it's a multiple choice, correct? So multiple choice, correct? I think so. So without saying anything, do you see the question? Yes. I hope you understand the question. This is how the question is framed. A cubical region of side A has a center at the origin. It includes three fixed point charges, minus q, plus 3q, and minus q. Choose the correct option. Choose the correct option. Remember, the center is at the origin, so just understand the center is the origin. Three Q is placed at the center, and one is placed at minus a by 4, and the other one is placed at plus a by 4. A by 4, remember. Okay. Let's see. Remember, it's all about symmetry. It's all about symmetry. This question is not asking you how much is the flux. They're just asking you the symmetry, 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 and symmetry, and symmetry, and symmetry. Now, this is how you, once you do a question, this is how you must be able to get the answer and stay happy. Remember, staying happy is important. Yes. I think this is a multiple choice question. So, no.
Sir, C is correct, sir.
I don't know the answer. I'm looking at the answer. I'm just trying to find out where is the answer. Question number 15 it is. Okay. Let me go to the answers. Also, I had to open a lot of things so that where is that? Where is that? Where is that? Where is that? Arey yaar, kidhar hai? Oh God, so back. I have not read the option. I just found out the question and gave it to you. Now I'm going to look at the answers. I said question number 15, right? Where is? What is the answer?
C is correct, sir.
Arey, I am not
C,
getting
sir. Option C.
option C. Arey, where is that? Answer is not there, look. How do I check now? How do I check when the answer is not there? Here. Here are the answer of this one. Question number 15, and the answer is given as no answer. Right? Yes, I got the answer. The answer is given as A, B, A and C.
A, C, D, sir.
A and C. The answer given is A and C. How many of you got this? Great. So that means you understand it. Now let us break it and find it out which answer is there. The easiest one is to get the net flux. Net flux crossing through the entire region. So it's a cube. It's a closed space. So you just have to find out the total charge, and I think the total charge is Q. Q by epsilon naught.
Yes, sir.
The option C is definitely correct. Remember, the most difficult question in a JEE are multiple choice, because there is a high chance that you might mark one options wrong. So if you know that one of the options you have marked is correct, just move on. If you cannot get the other answer, just don't mark anything wrong. Because if you mark anything wrong, your right answer also becomes wrong. Do we understand this?
Sir.
So if you don't understand the question, you know that option C is definitely correct. So just mark option C and move on. If you can't understand the rest of the parts, that is one of the lessons that I had to tell you. Okay. Now remember, because of this plus 3Q, all the faces will have equal flux. Yes or no?
Yes, sir.
So basically what we have to see is what is happening because of the other two charges. If you can understand this, we are done. So remember, your x-axis is like this here. So the first option is net flux passing through the plane plus a by 2 is equal to the net flux passing through the plane minus a by 2. Now remember the two charges. This is the center. This is a by 4 plus a by 4. Then this is minus a by 4. Then I will have plus a by 2 and then I will have minus A by 2. They are symmetrical. And remember, because of the central thing, every flux is same, right? Yes or no?
Yes, sir. Yes,
So
sir.
is this option correct? Symmetry. That's what you have to see. Is option A correct? Yes or no? They are
Yes, sir.
symmetrical with respect to them, right? The only two charges you have to understand, because rest of them all are same. So the option A is correct. Do we understand this? Symmetry. Nothing else but
Yes, sir.
symmetry. Let us now look at the second option. The net flux crossing the plane x is equal to plus A by 2 is more than the flux passing through y is equal to minus A by 2. Now y is equal to minus A by 2 is your this side ka phase and this side ka phase. Which flux is more and which flux is less? Or are they same?
The same, sir.
They are same, sir. Do we understand this, sir? Everyone in the class, do you understand this?
Understood, sir.
Well done. The net passing through the flux passing through the plane z is equal to plus A by 2. So he's asking about the top, and x is equal to plus A by 2. That means he is talking about this phala phase. Is it same? This is wrong. By symmetry, they must be same, but by symmetry, they are different. Yes or no?
Yes, sir.
Because your charges are placed along the x-axis. And you're talking about one plane on the y-axis, one plane on the z-axis, and one plane on the x-axis. They cannot be same. Yes or no? So these are the answers. A and C are the correct options. Do we understand this? Yes or no? It has gone about saying bye bye, sir. This is gone. This is gone. Symmetry. Gauss law is all about symmetry. Gauss law is all about what?
Symmetry.
If you understand symmetry, you will understand everything. So I'll give you one more here, and then probably I'll show you questions from the previous year, and probably that will make more sense, so that you understand what type of questions you can expect. This is the last combination in that cube wala thing. This is the last of the combination where you have a cube placed at one of the edges. Edge center. No, not the edges. It is the corner center cube. Now again, you have 6 faces through which 6 phase flux is same, flux is 0, flux is same, flux is different. You have to tell me the answer. First, you tell me the answer, then you have to tell me flux through one of the phase. Forget about this question. First, try to understand through which phase flux is same and through which phase flux is different. You can name it if you want. So I'll name it for you so that it becomes easier for you to understand. A, B, C, D, E, F, G, H. You have 2 minutes to show your talents, else I'll show mine. Do we understand this, or this is going above it saying bye bye? Bye bye, sir, bye bye. निकल लिया सर ऊपर से हैं? Do we understand, or this is going bye bye?
Trying, sir, question.
Okay, trying question. Okay. Which one? Chalo, I've given you time, right? I must be patient. I know, I forgot in the previous question, not this one, this one. I forgot to ask you, what is the, yes?
Option D.
I moved on to this question. I forgot to ask you one question. What is the flux through this entire cube? In this question, what is the flux through the entire cube? What is the flux through the entire cube? Just first answer this one, and then we'll go ahead. In this question, what is the flux through the entire cube? When I had a charge placed at the center of the edge, what is the flux through the entire cube? Can I have the answer for that one? What is the flux through the entire cube in this case? Huh? No one knows the answer? Huh? What is the flux through the entire cube? I forgot to tell you that. Yes? I heard some murmur, some sound. It is died down.
By 2 epsilon naught, sir.
Q by?
Q by 2 epsilon naught, sir.
Q by 2 epsilon naught.
Q by 2 epsilon naught was the case when it was at the face. This is not Q by 2. This is not Q by 2.
0, sir.
Flux of the entire cube is 0. Akkad bakkad Bombay wo 80 90 pure. So I have seen a trick, the so-called tricksters, and I saw this trick sometimes ago. Some of those tricksters on YouTube was I told you that trick, na? How to get answers quickly. If you find 0 somewhere, that 0 has to be the answer. That is akkad bakkad Bombay wo 80 90 pure 100. This is the cube. It is placed on this edge here, center. Do you understand this? Bigger picture might help you. It is placed here at the center of this. Do we understand this? Now remember, symmetry plays a very important role in Gauss law. I will have to enclose this entire charge. How will I enclose this entire charge? It is at the center of this one. So I put one cube here like this. So 1 plus 1, 2. But then I will only enclose the half of this. So then I will put one cube like this in front of this, and then I will put one cube like this. So now it will be at the center of these 4 cubes. So basically what I have done,
Q by 3 epsilon naught, sir.
is to enclose it, I need 4 cubes, my dear friend. How many cubes I need? 4 cubes to enclose it fully. And therefore the flux through this one cube is Q by 4 epsilon naught. I need to put a cube here in front, side by side of this one. Then I need to put a cube here in front of this one. Then I need to put a cube in front of the second one. Now it will be exactly at the center of these 4 cubes, and the flux through any one of the cube will be Q by 4 epsilon naught. Do we understand this, or this has gone above our head saying bye bye? Do we understand this? Yes or no? So I need 4 cubes to enclose it completely, symmetrically. So one of the cubes is only enclosing 1/4 of the charge. When, and that is chemistry, BCC, FCC, H center cube. When it is inside the cube, only one cube can share it. If it is on the face, two cubes can share it equally. If it is on the edge, four cubes have to share it equally. You understand this or bye-bye?
Understood, sir.
So the flux through any one of this cube will be Q by 4 epsilon naught. Do we understand this? That takes us to the present, and this is the question in the present. Now, I think the answer would have changed drastically from the answer that you had given before. Now, the first question is, through which faces is the flux same?
Q by 8 epsilon, sir.
Yes, the answer is Q by 8. No, Q by 8 is wrong. Now, remember this charge is placed here. This charge is placed here. This charge is placed here. Now it is in contact with three faces. It is in contact with the upper face. It is in contact with this face. And it is in contact with this one. It is in contact with three faces. Number one, the upper face. Number two, piche wala, and number three, aage wala. It is in contact with these three faces. Flux through these three faces would be how much? Flux through these three faces would be 0. So this one, and this one, it would be 0. Do we get this?
Yes, sir.
Yes,
The
sir.
remaining three faces will be symmetrical with respect to this. So flux through those three faces would be same. Do we understand this?
Yes, sir.
Now I have to enclose it. Remember the charge is here. How many cubes will I need to enclose it? How many cubes will I need to enclose it?
6, sir.
Huh? How 6? See, it's here. So I put one cube at the back, one cube here, and one cube here. With 4 cubes, I would only be able to
7 cubes, sir.
7 nahi 8. How can it mean 7? 1, 2, 3, 4, 5, 6, 7, 8. I will need 8 cubes to enclose.
7 additional cubes we are saying, sir.
7 additional cubes. Flux through any of those cubes through the entire bigger structure will be Q by epsilon naught. Through any one of the cubes, the answer will be Q by 8. But through any of the faces, it will be 1/3 of it because all the three faces are symmetrical. So through any face, it will be Q by 24. Do we understand this? It has gone above और saying bye bye, sir निकल गया.
Understood, sir.
How many के ऊपर से निकल गया? Gone above our heads.
Understood, sir.
पक्का no sir?
Pakka, sir.
कच्चा पक्का पक्का पक्का.
Pakka, pakka.
ये पक्का पक्का is not looking good. पक्का पक्का. पक्का ना?
Understood, sir.
If you still need more help, this is the diagram that might probably help you in what I was trying to say. When you have a face center cube, only 2 cubes are needed to enclose it through any one of the faces. Through any one of the cubes, the answer will be Q by 2 epsilon naught. If you have a edge center of the edge, you will need 8 cubes to enclose it, Q by 8. If you have at any vertex, you will need 8 cubes. At any edge, do you see this edge? You need 4 cubes, Q by 4. Do you understand this?
Yes, sir.
Sir.
Pakka, no, sir?
Pakka, sir.
Pakka, sir.
Then you can and these are other questions that can come, so I'll just you have noted this down.
No, sir.
And what are you doing, sir? Don't waste your time, sir. Please note it down, sir.
Noted, sir.
I've already told you this, right? This is just a diagram. You may not be able to draw the diagram of all those cubes enclosing it. You just have to understand it. Okay.
Sir.
Again, this is just a recap of whether you have a electric field which is constant, it is moving through this. I told you if it is a closed surface, the flux is going to be 0. Yes or no? So this is the illustration. This is a better diagram that probably I would have made. The better diagram, it looks like this. Do we understand this?
Yes, sir.
It's just a better diagram and nothing else. Then these three. Again, I think I have covered them in the class. If not, you can just see them and understand what is happening here. I've covered this question whether it was when it was placed at the center of the hemisphere. I told you I showed you now. I showed this question in two different ways. I showed you by the electric
Yes,
field
sir.
E into
Yes,
2
sir.
pi r square. Now you can do it by the Gauss law. You enclose it with one more sphere, hemisphere, and now it will be at the center of that bigger sphere. So flux through any one of the parts will be q by 2 epsilon naught. Do we understand this?
Sir.
This is how it is done now. I did it with the electric field wala tarika. Then you have a charge at the circular part of a cylinder. You put one more cylinder, q by 2 epsilon naught. We understand this? Huh?
Sir.
You can see what type of question comes, and this is all JEE advanced. And you will be surprised to see what question there. I did not remember this question, but see, this question already came, which we had done in the class. It's already came. Anyways, I did not know it. This one.
Sir, show previous page.
So previous phase? Huh? Why are you always in the past? But thank God I have a time machine that I can take you back. If I would not have one, then probably I don't know what would have happened. Time machine is the best best ammunition that I have that I can take you back. Otherwise, I don't know what would have happened. Done? Yes or no? No, yes.
No, sir.
No, sir. Okay, do it, sir. I will give you time, sir. I have no other option, sir.
Done, sir.
Done, sir?
Yes, sir.
This question, sir. JEE Advanced 2017. We are only concerned about that part where we are talking about flux and field. The last part, equipotential, we are not concerned right now. So D part is out of course. A, B, C, I think, are in course. A point charge plus Q is placed just outside an imaginary hemispherical surface of radius r as shown in the figure. Which of the following statement is /r correct? JEE Advanced. Dun, 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 dun. Dun, 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 dun. Dun, dun, dun. Any idea? No idea. Get idea. D is out of course. We can only work on A, B, and C. And what is the answer for anyone? No one knows the answer. Yes, bacha.
Sir, option B correct.
Option B correct. Remember, it's a multiple choice question. If you give me one on wrong answer, you get all undas. No, not undas. You get minus. Option B is correct. Accepted. Option B is correct.
Option A, sir.
Option A correct.
Sir.
How did you get it? Option A is correct. See, you are solving JEE advanced question without copy and pen. D is out of course. So the only thing that is remaining is C. Remember, this is multiple choice. One wrong mistake and all undas, not undas, minus. So if you're not confident about the next one, you don't say anything. It says only these two. We'll move ahead. The third one is the simplest. Yeah. What is the total flux through the curved and the flat part? And the answer is
0.
0. That is the simplest one. That was the simplest one. That is how you found out this flux. Now, how did you find out this flux? How did you find out this flux? Huh? How did you find out this flux? You found out this flux using this concept, sir. That we already did, sir. Here, sir. The question was just put in a different way, sir. Flux through the entire thing is 0. That is the exact answer that you got, right? Yes or no, sir?
Yes, sir. Solid angle. Solid angle.
Yes, that is the only way you can get the answer, beta. And you got the answer because you knew that the total flux is 0. So the answer C is the first one that you should have given. Sir, C is correct. What about the others? I don't know. C is also correct. So remember, if you just do simple things correctly in life, JEE Advanced is simple. And as I keep on telling you, multiple choice is the most difficult type question in a JEE. Because that is the question that gives you the most negative marks. That is a question that you must be very, very careful while attempting any JEE. See? This one. Electric field. I think you can do this. Chalo. This is again JEE Advanced. Let's see how advanced it is. You have 2 minutes to solve it because it is already 5:26. You'll get 2 minutes to show your talents. I'll get 2 minutes to show mine. And remember, you don't even have to use copy and pen. Without copy and pen, you can do this. Because these are questions from JEE Advanced. And the question has to be simple. That is why it is there. The question was difficult, it would not be there here. An infinitely long, thin, non-conducting wire is parallel to the z-axis. Remember, most of the cases in JEE, whenever they are going to make the coordinate system, they are going to make it like this. This is going to be their z-axis, this is going to be their y-axis, and this outward axis would be their x-axis. That is how they will make it. So don't get confused. The infinitely long thin wires, non-conducting wires parallel to the z-axis and carries a uniformly lined charge density lambda. It pierces a thin conducting metallic shell of wire in such a way that the R PQ subtends an angle 120 degrees at the center of the speaker shell as shown in the figure of perpendicular phase with the following is true. Which of the following statements are true? It cannot get simpler than this one. The electric flux through the shell is this, ding ding ding. The Z component of electric field is ding ding ding. The electric flux through the shell is ding ding ding. So out of A and C, only one can be correct. And the rest is simple theoretical. Your time that remains on your clock is only 1 minute, my dear friends. 1 minute. 8 minutes. Only 1 minute. 1 minute. 8 minutes. Anyone with anything that looks like an answer? If it looks like an answer, it might be the answer. Eh? No one. Shameful, shameful. Shame, 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 shame. You cannot do question of JEE Advanced. Shame, 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 shame.
Sir, be correct.
Yeah, see, remember, it's a multiple choice. The most difficult question in JEE Advanced. If you don't understand anything, just leave it. B is correct. The line charge cannot produce field in the same direction. So if B is correct, then D automatically becomes 0. Yes or no? So you are going to get +4. See, only A and C. You just have to find out how much is the charge enclosed, and you are done. And how to find out charge enclosed? This question can be done by a 7th standard person. 7th or 8th, not more than that. Because you just have to find out how much is the length of this line. Yes or no? Huh? Once you know the length of this line, you multiply by lambda and you get the charge enclosed. When you get the charge enclosed, you divide it by epsilon naught, you get the flux. Yes or no?
Sir.
And the answer is A. So A and B are correct, and C and D are absolutely wrong. Do we understand this, or this has gone above it saying bye bye? Bye bye, sir. Enough. Huh?
Understood, sir.
Understood, sir.
Understood, sir. So this is the closing statement from my side, and you will imagine that this is we have done much more difficult question than this one. This is the question that came in one of the JEEs. Now, not looking at this question, I did not make my question. I've been making this question since before this question came. Consider electric field is equal to E naught x, where E naught is constant of flux through the shaded area. I think you can do this. Yes or no? So I'll get that as a homework. Electric field is along Z axis. Then you have this thing. Can you find out the flux through this thing? I will leave that for you to answer. Remember, there is nothing that can come in a paper of JEE that I have not taught you. The only thing is how much of that you can recollect and apply in the final exam. That is what that is going to make the difference. Okay, so I will wind out this class now, and I'll see you on the next side of the week on Monday. And Monday we'll start with the applications of Gauss law and see some more questions that have come, that can come, and how does Gauss law help us in solving them. So take care. God bless you. Bye bye.
Sir.
Sir, tomorrow do you have class?
I think yes.
Sir, which area is shaded there?